Let's learn Docker. You ever send a code to your friend and he replies to you saying like it doesn't work on his laptop, which is a classic developer issue? That is what Docker is trying to solve here, and also why it is used almost everywhere. So why does it happen? It could be because of different operating system, different dependencies, different version of software. So like you might be using Mac OS and your friend is using Linux. Or you're running it on Python 3.11 and your friend is using Python 3.9. Now the exact same code works completely different, and it has become almost impossible to debug. So what does Docker actually do to make this possible? It just packs everything your application needs into something called a container. It will be having your code, your runtime, your dependency, your system tool, everything. So it will be literally a container that can sit on any ship without any issue. Just the same result, and your code runs fine basically everywhere. So technically on a surface level, when you run Docker on your computer, what happens is that you are running a mini computer inside your computer so that it can run any application it wants without having any dependency issue. Let's see how you can install Docker on your system. For that, you need to go to this website, docker.com, and then you need to hover on download Docker desktop and just pick the OS that you're using. Windows, Mac, Linux, anything. In my case, it is Mac, so I'm gonna go with it. But so if you're someone who's using Mac and you have installed Docker desktop, there can be a chance that it is too huge for your system. And if you're someone like me who wants something really light, you can go with OrbStack. So to install that, you just need to go to this website, orbstack.dev. And in case you're thinking that they're sponsoring this video, but nope, they're not. So you just need to click on download. Once you click on download, you will be taken to a page like this. And from here, you need to click the one that you're using. In my case, it is download Apple Silicon. Or when you scroll down, you can run this one, brew install OrbStack, the one that you have brew installed on your Mac. Once you're done with all of that, you will have a GUI pop up on your screen, where you will be having all the information about the containers that are running, in case if there are any. So that is pretty much about OrbStack. Let's just focus on Docker. So once you're done installing Docker, we can verify that by opening up the command prompt. For that, all you need to do is just type in Docker version. And if Docker prints any version number, congrats, you have installed Docker on your system. You have officially turned your laptop into a container factory. So before moving any further on Docker, there are like few concepts that you need to understand about Docker. Docker has mainly three building blocks: images, containers, and Dockerfile. Docker image is basically a blueprint. If you want to run a container, you first of all need a Docker image. It basically defines what environment your application needs. For example, the Python version that is required, the dependencies, and also copying the entire code. Think of it as a snapshot for the environment that is required for your application to run. And also, images are static, they don't run anything. It's just that for a container to exist, an image is required. So what is container? Which is the core concept which I've been saying since the start of the video. A container is basically a running instance of your application. Like you take in the image, you just run it, and that becomes a container. Also, containers are the ones that we can start, stop, restart, and destroy. And moving on to next, what is Dockerfile? Dockerfile has to be the starting point of this entire thing. So a Dockerfile is an instructional manual Docker uses to create an image. Think of it as like basically a script that tells Docker what the image should look like. It will be having all the information about the base environment that needs to be used, and the code and the runtime dependencies and all that. So the flow is you write the Docker file, it just creates an image, and the image will create a container. So one of the theories, let's just see how we can run a container on our system. For that, I don't have to build a container from scratch. I can just use ones that are pre-built from something called a container registry. In case you didn't know, container registry is kind of like a warehouse full of containers, different applications that are been containerized. And what I can do is that I just can import that container and run it on my system. We have a few really famous registries that are commonly used, like Docker Hub, GitHub Container Registry, Google Artifact Registry, and AWS ECR. For this example, I'm going to be using Docker Hub. I'll be trying to run Nginx. In case you didn't know, it's basically a web server, also used as load balancer, reverse proxy, and and the use cases are endless. It just depends on how you want to use it. So let's just see how we can run an Nginx on our system by importing the container from Docker Hub. So for that, all I need to do is just type in docker run d. D is for detached and D is for port. So here the port number is going to be 8080, and the port that is inside the container is going to be 80, and I just need to mention Nginx. So let me just walk you through the the flags in the command once again. So the D means detached, which means it will be detached from the terminal. So even if you close the terminal, it will still run in the background. And P stands for port, the port that we need to access the application that is running inside the Docker. So in case here it is Nginx. So the Nginx will be listening to port that you see on the right side, which is 80 inside the container. And from the outside, which is like for us, we need to access 8080. So on the left side, it is the port that we need to access, and on the right side, it's the port that is used by the application inside the container. Just click on enter and see what happens. Okay, the reason why we are getting this error is because I misspelled Nginx, which is something that commonly happens, I guess. Or is it just me? Should have been Nginx, but I wrote it as Nginx. Okay, let's just see what happens now. So it says unable to find the image. All right, so at first it said it was not able to find Nginx image locally, and then it pulled the image, and now we are downloading the entire image. Once it's been downloaded, and the container will be up and running. How can I check if it is up and running? Access 8080 and see Nginx server been up and running. Let's just confirm that once. 8080. That's it. It says welcome to Nginx, and if you see the page successfully, Nginx is installed on your system. So that's it. Let me just run you through what happened when we ran docker run detached port 8080 and Nginx. So what literally happened under the hood is, so at first you can see the Docker was trying to locate the image on our laptop locally, and it was not able to find the image. So what it does is that it pulls the image from the hub, and then it creates the container from the image that it has got, and the container is now up and running in the port that we mentioned, which is 88. So that's pretty much it. This is really cool. We just ran our own container. Now let's just move to the other step, that is building our own container from scratch. So for that, as you know, if you want to create a container, what you need is an image. And if you want to create an image, what you need is a Dockerfile. And if you want to create a Dockerfile, you at least need an application, right? And in this case, I'm going to be building a simple Flask application that returns, hello, Docker is running. So let's just write some code. Let's just go to anti-gravity, create our simple Flask application which returns, hi, this is Docker. I'm gonna ask my AI to just create a Flask application for me. Let's just wait. Okay, so we have got our Flask app created, and let me just run that real quick and see if it is working. Let me accept the change. I will run the Flask app and see if it works fine. Just need to do Python create a requirement file. I'll ask the AI to create a requirement file as well, because that is quite important if you want to create a Docker file. And we don't have Flask installed, as you can see. And it just created a requirement file. Copy this command and paste it over here. Okay, the Flask is installed. Okay, let me try running the Python app now. So just the 500 port is already in use. So I just can go ahead and do another port. Let's just see 8000. Okay. I can access just the local host. Our web server is up and running, and it just says this is Docker. Now let's just see how we can containerize this web server. For that, you need to write a Dockerfile like we saw in the beginning of the video. So for that, I just need to type in Dockerfile. That's the thing. Now we have Dockerfile open, and the first thing I need to mention is the base image that I want to use. So this is a Python application. I'm gonna say from Python 3.10, 3.11, whatever that is. So that's like my base image. The next one, what I need to do is set my work directory, and that is going to be app, which I will tell you. I will explain what all of these things are in a moment. And let me just copy the requirement text, and let me just run. All right. So let me just walk you through what the entire Dockerfile is, and like every single line of what it is. So the first one says from. So that means like the start of the entire Dockerfile. We have to mention the base image. So in this case, we are running a Python web server, so it has to be Python. So let's say if you are using a Node.js, base image will be different. Or if you are running something on Linux or Ubuntu, if you want to have that, the base image will be, you know, different according to the application that you're running. In my case, since I'm running Python application, it is Python. The next one is a work directory. So this one refers to the directory inside the container. We are initializing app as the work directory inside the container. So everything that we copy, everything we take from our local laptop will be copied into this work directory inside the container. This is what we did in the third line. So the third line says, the fifth line, but you know, third line says copy requirements.txt. So we are copying the requirements.txt from the local laptop, from our system, into the Docker work directory. The dot represents the work directory inside the container. So in this case, it is app. And then we are running install requirements.txt or txt. So what that basically does is we are just running all the dependencies inside the requirement file. In our case, it is Flask, but if you are having any other dependencies, any other packages, everything will be installed inside the Docker, because inside the Docker is just fresh. That's the case. And the fourth line or the ninth line, we have copy dot dot. What the first dot represents the current directory on our local system. So in this case, that is Flask app. Every file inside the Flask app will be copied into the work directory of Docker. In this case, this is the dot. But that dot represents the work directory inside the Docker. Basically copying all the files from Flask app, which is the current directory or the place where the Docker file exists, into the container. And this line, which is the 6th line or the 11th line, this is command python app.py, which is a command that runs the application inside the container when the container is up. The last one is expose 8000. So this line mentions like the port that the application is getting exposed to inside the container. And one thing you need to notice is that the expose doesn't explicitly make the container listen to the port 8000. It's just for the person who's, reading Dockerfile. So basically, whatever port that you mentioned over here, it doesn't matter. It's just for the readability of Dockerfile. So now let's just see how we can run this Dockerfile and create an image and run the container. For that, let me open up my command prompts. So just build the Docker image first. And so to build an image, what I need to do is just type in Docker build. T represents tag and my app, which is the name that I'm going to give my image. Okay, and the dot represents the current directory that we're part of, and the image has been built. Okay, I forgot to save the Dockerfile. Okay, let's just run it again. Now you can see the image is getting built, and that's it. The image is up. So how to check if the image has been built or not? For that, I need to like type in Docker images. So when I type in Docker images, I can see all the images that exist on my system. In this case, I can see my app, Nginx, and Open Web UI, which is a UI for local LLM that is running in your laptop. In case you want to check out, you can check out the video that I did. It will be somewhere over here. As you can see, my app, which is the latest image that we built, and it was created 9 seconds ago. I'll just see how we can run a container, how we can build a container from the image that we have. For that, I need to type in docker run D for detached, P for port number, and here I'm gonna give 5000. So like 5000 already exists, right? So let's just change that to 8001. So we have to access 8081 from our laptop to access the application which is inside the container. And inside the container, the app will be listening to 8000, as mentioned on the right side of the port. So here I'm mentioning the name of the image that needs to be used to create the container, and this is the name of my container. So let's just okay. So right now the container has been created. So to list all the containers that are running on our system, we just need to type in docker ps, which gives all the containers that are running. And on my system, we have Nginx running and my app running. So this is the port that we mentioned while creating the container. And this is a port the application will be listening to inside the container. So let's just try accessing the application inside the container by typing localhost 8001. And there you go. So localhost 8001, we are accessing the port that is open for us from the container that is 8001, and then inside the application is listening to the port number 8000. So the port binding happens, and that is how we are able to listen to the application inside the container. Yes, you have created your own first container if you're someone who's getting started, and yeah, that's about it. Also, let's just see a few Docker commands that you will be probably using if you are someone who's handling, or if you will be handling Docker in the future, that are docker ps, to list all the containers. And if you type in docker psa, it will list all the containers that are even dead, like not running at all. If you want to stop a container, let's say, you can either copy in the container id or the name. So let me just copy the container id, and I just can say docker stop, and it just stops the container. So when I do docker ps again, I won't be able to say my Nginx because I stopped it. But when I do docker psa, I'll be able to see Nginx, all the containers that are up and down. So Nginx container is stopped right now. Let's just say you want to remove Nginx from your system. For that, you can type in docker rm, and then I need to type in the container id, which is this, and there you go. The Docker image has been completely removed from your system. And when I type in docker psa, I won't be able to find Nginx because it's been removed from my system. Okay, so that is a quick peek into the entire Docker container and all those stuff that you will probably be using if you are getting into the infra side of things. And the next thing is, if you had noticed here, I have used Python 3.10 Slim, which indicates a smaller base image. So when we were creating the container, it didn't take that much of time. The build didn't take that much of time. That is because we have used Slim image, which is a lightweight image, instead of using just Python 3.10. So if I was using Python 3.10, it would have taken a much longer time compared to using a slim lightweight image. So it's highly recommended to use a lightweight image if you want a faster build and if you want to deploy faster. And one more thing is the order in which I have written each line. So there's a reason why I have copied requirements.txt file first, and then I copied the entire folder after installing all the packages. The reason being that the Docker, how it works is every single line that you wrote in Dockerfile is cached, so that when you are building again, it takes lesser time. So what happens is, if you are trying to copy the entire folder first and then running the requirements.txt, if you are making any changes to your code, that line will run first, and then it will install all the libraries and modules once again. So if you are copying the requirements.txt file first and then installing that and then copying the entire code to your container, so even if you are changing something in your code and then building it again, the first 4 lines won't run because it's been cached and nothing has changed. So things change from the 5th line, which is the code that is being copied into the container. So only that layer gets built again. So in short, it just makes the build faster because we are not copying the whole folder first and then installing the libraries, because we are installing the libraries first and then copying the whole code. So in case if we are making any changes in code in the future, the libraries or the modules won't be installed once again because it's cached. That is the reason why it is always recommended to copy the requirements and install the libraries first and then copy the whole code to your container. And also one more thing, containers are ephemeral, which means if you delete a container, all the things, all the data inside the container will be deleted, gone. And to prevent that, there's another concept called volume mount. So whatever data that is used inside the container will be stored on your laptop or on your system locally, which is like another concept maybe for another video. So yeah, that's pretty much about Docker, and you have now become a Docker expert. I mean, not an expert, but you at least have an idea about what Docker is and how to run your first container and how to even build your own container and all that. So next time when your friend says code isn't working on their laptop, all you need to do is just containerize your application and send it to your. So with Docker, it just works everywhere. So we just saw how one container has been built and handled, but in real world we have tens and hundreds of containers. So these are handled by stuff called Docker Compose or Kubernetes, which is a topic for another video. And in case if you have any questions or anything, just let me know in the comments, and I'll see you next.